Hello everyone and welcome to this course on modern application development. So with all of that in mind, this notion of REST, as I said, it stands for representational state transfer. What does it actually mean? It means that the state of the interaction, right, between the client and the server. So there is some interaction. If you are on a shopping website, shopping carts, right, there is a notion of what is the present state of the interaction. Are you in the process of buying a certain object, right? A lot of that information needs to actually be transferred back and forth between the client and the server. Okay, now a shopping cart of course is different. The server actually retains the entire shopping cart at its end, right, in a database somewhere. But how to add something to a shopping cart, how to sort of are you in the process of adding, are you clicking on something and adding it to the shopping cart, are you removing something from the shopping cart, what is the present state of the shopping cart? All that information needs to sort of go back and forth between the client, right, with every communication. The entire contents of the shopping cart don't, but the exact nature of the specific interaction that you have at this point has to sort of shuttle back and forth. And that state transfer between the two, right, is happening by means of some kind of text-based representation, right? And ultimately, it need not be text-based, but a sort of standardized representation format. Okay, and that essentially is what allows us to sort of build such distributed architectures in a robust way. Okay, so a typical sequence of how a REST-based communication could happen between a client and a server would be something like this. A client accesses a resource identifier from a server. So what's a resource identifier? It's something that identifies, maybe a shopping cart, right? Usually this would be a URI, a uniform resource identifier, right, which stands, so URI stands for uniform resource identifier. You are probably more familiar with URL, which is a uniform resource locator, right? The URLs are that line of text which comes on the top of the browser, which is sort of the address of the website or the page that you are visiting. The URI is sort of a superset of the notion of a URL, right? It can refer to certain things which are not necessarily HTTP web pages, and it has a very specific, it includes a protocol as well as some kind of information about what identifies this particular resource. Okay, and the way that the client would go about accessing this typically would be that you start from the home page of the application, and in that there are a number of other links that tell it what are the other resources that can be accessed from this place. Okay, once the client has accessed a resource in identifier, along with accessing the resource identifier, you also need to specify a resource operation. What do you want to do with the resource? Do you want to just get it, that is read it and display it, or do you want to put some new information onto it, right? Do you want to, let's say, create a new blog post somewhere, okay, or post a comment on Facebook? Okay, now in the case of HTTP, that resource operation would typically be the verb, right? Something like a HTTP get or an HTTP post. But the important thing to keep in mind is REST is not necessarily tied to HTTP. Just so happens that HTTP is one good way, one good sort of platform that can be used for implementing these ideas. Okay, and finally, so what has the client done? It has requested a resource identifier along with a type of operation. The server looks at both of those, decides what to do, identifies what it needs to send back, and basically sends back a new resource identifier. When I say new resource identifier, this could just be basically a new page that comes back to the client, and the client then decides what to do next. Okay, so in this way, look at what has happened. We have not really assumed any kind of state on either side. Client sends a request, the server just looks at the request, it doesn't assume anything else and responds based on that. Now the server has other information. It, for example, might know from the request, basically maybe there's a cookie as part of the request, which tells the server that yes, this client is actually logged in, and based on that I need to respond in a different way. All that is fine. So that's not what REST is talking about. REST is not saying you shouldn't do that. That is perfectly fine, but what it's saying is at any given point in time, if this was the request from the client and it included this cookie, it showed authentication and so on, this is how the server should respond. Okay, you can't assume anything else about the client. such as that the client is currently on or that the user is staring at the screen. None of that is possible. So this state of interaction at any given point in time, do I want to add something to the shopping cart? All of that information, what is required over there, needs to be transferred back and forth between the server and the client. Not all of it. I mean, I don't need to kind of transfer the entire contents of the shopping cart, but sufficient information that I can update the state and get a new representation of where I am in the system. HTTP is one possible protocol to carry REST messages, right? It's not the only one, but it is the most common, right? And what is done in this case is that the HTTP verbs are used in order to indicate actions to be performed. Get, post, put, delete, most common ones, right? And certain kinds of functionality can therefore be standardized by having specific meanings associated with those operations. So get typically means retrieve certain representation of a target resource's state, right? Post, on the other hand, will typically have some enclosed data. Whenever you are doing a post request on HTTP, it means that there is usually some kind of a text box or something that you have filled out and submitted, or some other parameters that you have clicked in a form. And what happens is that you are effectively telling the server, right, the target resource, right, every request to the server is actually a request to a specific target resource, because after all, the way that we have looked at it is any request that we are sending is a URI of some resource which is there on the server. So the way to look at this is the post is also providing some input to that resource which tells it how to update, either create a new instance of something or update some internal value and return a new resource identifier. What should the user go to next, or what should the other side, the client do next after this. Put is sort of a bit more clear than post. It sort of says that usually the understanding of put is that it just basically creates a new resource, right? So assumes that there is nothing already in place, just creates space for a new resource, puts all the data that you have sent over there and sends back a success or failure response. Delete, easy to understand, right? Just delete the target resource. Okay, so these are all ways by which the HTTP verbs have been adapted for specific functionality within the context of REST. There is also this notion of what are called idempotent operations, right? And this is useful to understand. It basically says that repeated application of a certain operation is not going to cause problems. Okay, a simple example of that is that a get operation is almost always safe, right? I mean, when your understanding of get is just to read data, right? So you can basically read information as many times as you want without causing problems. It does not change the server in any way. So that's idempotent. You do as many gets as you want. It is not changing the state of the server. A put is also idempotent, right? It is changing the state of the server because it is creating a new element, but because of the nature of put, what it says is if you put an object once, right, or at least the way that put is defined, it basically says you are putting a specific object with a specific ID. Next time if you try putting the same object again, it will probably respond saying the object already exists. You can't do this one more time. Okay, but it's not going to create an extra object. So it's partly also how we define put, right? So if we say that put basically has this meaning, that I'm going to put a specific object with a specific ID, then it's idempotent, because if you try putting it more than once, it will just basically respond saying it's already in the database, you can't do this one more time, right? Delete is idempotent as long as you have given the ID to delete. Let's say I say delete item number 42, right? It deletes it. It does not change the IDs of any other items in the database. So next time you call delete item number 42, it might just tell you, look, you already deleted it, it's not there, right? But it's not going to change anything further. So you can repeat the process without causing problems. The post operations in general though need not be idempotent, because very often what happens with post is that we are saying create or update. Okay, so if there is something which is already there, it might try to update it, but if you are not given an ID, it would try to create a new object with a new ID. Okay, so one possible thing which you might even have noticed in certain cases is that sometimes there is duplication of comments, right? you have a blog or something of that sort, and somehow what happens is that you find that there are multiple comments with exactly the same text. What happened? A person basically clicked on it more than once, right? Clicked the submit button more than once. There's really no way that the server could know that this was not supposed to happen. It received 2 submit requests of the form. It's not going to compare them and say, hey, these look the same, right? It's just taking the data and deciding what to do with it. Creates 2 comments with exactly the same information. So post, in other words, in that context at least, is not idempotent. So this notion of idempotent operations is useful to keep in mind when you are thinking about the consistency of your application. You need to sort of remember that the end user could potentially do that. I mean, we all know that sometimes the machine gets stuck and we just go click multiple times, right? We are just furious with it. We wanted to do something, we click on a button more than once. That could be a terrible idea if it's going to basically charge you for 10 railway tickets instead of 1 that you wanted to buy, right? So how do you prevent something of that sort from happening? Those are notions that you need to sort of keep in mind while designing an app. So finally, so far we have got an idea of what REST is, right? It is that whole notion of representational state transfer. How it works we will look at with examples later, but why it works is what I was trying to explain on this way. Now, one important thing to explain over here is we already looked at CRUD, which is the create, read, update, delete set of operations, right? And these are database operations, right? Remember that they are not fundamental to the web, they actually come from the notion of a database. But they are typically a common set of operations that are needed multiple times in most web applications, right? Which means that they are a good candidate for REST-based functionality. These are actions that the user typically wants to perform, okay? And what usually ends up happening is that CRUD operations are implemented using REST, okay? But it's very important to keep in mind that REST and CRUD are not the same thing. It's just that they work very well together. So you can use the notions of REST in order to implement CRUD functionality, but CRUD applies to the database, REST applies to the architecture of the web application, right? So they are sort of talking about 2 different things, right? Now in all of this, so we have all these things that can be done using REST. One important thing to keep in mind is also this thing called the data encoding, right? Normally in a web server, when you make a request to the web server, you expect to get back an HTML page. But now that we have got this notion of REST is no longer talking about HTML pages that are going to be seen by a human being. It's talking about more machine readable information, right? So I want to be able to transfer some state information, right? And how that gets displayed to the end user is a different story. You could have some other client that decides how to actually display it. I want this to be done in such a way that it can be transferred between machines in an efficient manner, which means that just HTML may not be the best way of doing it. So then people thought, okay, maybe XML, right? Extensible markup language. Yes, XML can be used, was largely used for a long time in order to transfer sort of machine readable data between systems, right? It's a structured data format which is more extensible than HTML, but at the same time also you can impose better constraints on it to prevent like the kind of badly written HTML won't generally be accepted in XML. On the other hand, XML is also verbose. It's a bit difficult to sort of edit and write and so on, and even transfer around. And what came along at some point was this notion of something called JSON, JavaScript Object Notation, right? The important thing is all of these techniques are basically looking for ways by which you can take complex data types and transfer them over a text-based format in some way, okay? So the idea of JavaScript object notation was that if I am trying to transfer, let's say, some complicated information like the complete user record, right? I want to transfer all the information corresponding to a user because there was a GET request asking for details of a user. I don't, from the server side, I don't want to sort of format it into HTML and say, this should be the size of the font, this should be the location on the screen. I want to send the data and let somebody else take care of actually deciding the presentation part, the view, right? So the controller by itself, right, does not want to get back HTML from the server. right? It wants to get back data which can be fed into a view, right? That's the important part to keep in mind over here, right? And that data might be complex. It might have arrays of information. It might have a dictionary which has like different, hash map between labels and values, right? An example of that would be something like this. Let's say this is a user record, right? And what I have over here, for example, is it starts and ends with curly brackets. So this thing is one JavaScript object, right? It's a JSON object, okay? And inside this JSON object, there are many different parameters out here. And if you look at it, what is happening is this sort of looks like a dictionary, right? In Python, we already know what a dictionary is. It basically has a key and a value, right? Now, even though this is JavaScript, this might actually even parse directly as Python code, right? Or at least it is very easy to get something which will be able to read this and say, yeah, this can be converted into a Python dictionary. So what would the contents of the dictionary be? It would have one key called first name, which would have the label John, another key called last name, which would have the value Smith, a key called age with the value 27. Notice that 27 is not within quotes, therefore it's a different data type, right? In this case, it's a number or an integer, right? Whereas John and Smith are within quotes and therefore are strings. What about address? This is a key. What's the value corresponding to that? That's not a single number or a string even at this point. The value corresponding to address is itself a dictionary which has street address and postal code as its contents. Similarly, the value for phone numbers now uses the square brackets to indicate that it's an array, right? The first element of the array has a type, home, and number, some value. The second entry also has a type and number value. So in other words, this is an array of similar objects that are there inside it. Okay. So what has effectively been done is it's very easy to think of this as a class definition or an object. It's basically the complete data corresponding to a given instance of an object, right? And what has been done over here is that whole thing has been serialized, meaning that it has been converted into one string of characters that can either be printed out or can be sent over a network protocol. Okay, so this serialization of complex data structures is what is handled using methods like JSON. Okay, and typically what we find is that any API transfer format, right, whenever we are constructing an API, as we will see later, the assumptions we will make is that the input to the API is going to be some kind of a text format like HTTP, okay, the verbs in HTTP. The output could have been HTML, but it's actually more useful to have it in some format like JSON or XML, which is a bit more verbose, or there are other languages such as YAML, right, yet another markup language. Now, why are these things used? Well, because they are compact but complete representations of complicated data structures. Okay. The important thing is they are not the same as the internal server representation. What is the internal server representation? It's a set of entries in columns inside a database table. Okay. What's the final view presentation? It's going to be some nice looking screen with colors and text of different sizes and everything laid out nicely in an array. This information, on the other hand, which is actually being returned by the server to the controller so that it can pass it on to the view, right, is going to be in a neutral format. We typically tend to use JSON or maybe one of the other variants depending on what the conditions are. JSON is probably the most common at this point, right? So keep that in mind. What is happening over here? The model is returning this JSON data to the controller, which in turn passes it on to the view for display. Okay, and that is how an API works. It basically does this separation between the model and the view and allows them to communicate by means of the controller by transferring data in this format. Now, just one additional word, I mentioned this thing called YAML, yet another markup language. It's a very common alternative to JSON. It's used in a slightly different context. It's primarily used more for documentation and for configuration. So let's say you have some kind of a new application and you want to provide some configuration information for that, right? When you want to start it up, you want to say how many starter servers should be started, what the website name should be, right? Some information, some what's called metadata, right, about the application. YAML is very useful and effective for doing something like that, right? Why am I mentioning this? Because later when we get to the OAS, the Open API specification, this is actually one of the formats that is commonly used to represent specifications.